In this video, we're going to take a look at functions. Functions are basically an equation, or basically a way of stating a relationship between two values. And the two values are that of an input and an output. What basically happens is that we start with an input, basically one value, and then we put it into something called like a function machine, okay? It's basically really just a function, but you can kind of think of that as like a machine. It takes this input, takes this number you put in, and then it changes it somehow, and then will spit out a value, which we would call the output. Okay. So let's look at an example. For these first two, I'm going to go ahead and show you what the rule is. Okay? So, for example, I have an output equaling the input minus 3. So what that means is if I start with an input of 6, my output will be 3 less. In other words, 3. If my output is 4, well, I subtract 3, I get 1. If my input is negative 1, I subtract 3, I get negative 4. If I put an input of a 90, I get an output of 87. Okay, so basically I'm just keep subtracting 3 from whatever number I input into the equation. This can also work for relationships where I multiply. For example, my output might be my input times 3, which means if I put a 0 in for an input, my output would be 0 as well. Because 0 times 3 is 0, which isn't one of the best examples with 0. So let's take 1. 1 times 3 is my output's going to be 3. My input's going to be negative 2, multiplied by 3, get negative 6. My input is 9, I multiply by 3, I get an output of 27. Okay, so basically it's I pick a number, put it in my input, I let the function machine take effect, and then it gives me my outputs, which are directly related to the inputs. Sometimes you might see a chart where you see what the inputs are, you see what the outputs are, but you don't know what the function machine is. So I have the output will equal the input, but I gotta figure out what's being done to the input. So my recommendation is start with addition or subtraction. So in this case, I could say, how do I get from 0 to 6? Well, it seems like I add 6. But I can't stop there. 1 to 7, well, that adds 6 as well. 2 to 8, that adds 6 as well. Okay, 3 to 9, add 6 as well. So I have the output equaling the input plus 6 for this particular situation. If I go through this, the relationship I have here is different from the relationship I have here in terms of addition. Then I want to try subtraction, okay? Might want to try multiplication or division as well, okay? To see if I can figure out what's this function rule, okay? That's happening. There is one set of vocabulary words that becomes very important, and that's of independent versus dependent variable. Okay, whenever I start talking about these functions, I have two values. I have an input and I have an output. Two other ways of defining that is the independent variable and the dependent variable. The independent variable is my input, because I can plug in whatever I would like for it. But then once the function machine takes effect, my output depends on the input. So therefore, I call the output the dependent variable, because it'll always reflect back to the independent variable. So we sometimes deal with real life situations, particularly in science, where we start wanting to compare two values in real life. Sometimes it can be confusing what's going to be the independent, what's the dependent variable. But you can always phrase it as what depends on what. So, for example, our first example, we have the age and the weight of an octopus. Does age depend on weight? Or does weight depend on age? Well, if you're not sure, ask your parents. But somehow I think that your age is going to be your age no matter what. That your age won't change because of your weight. So I think I'm going to cross off this one. But if I look at my second statement, weight depends on age. Well, yeah, if you're dealing with a 1-year-old child versus a 10-year-old child, I would hope that the 10-year-old weighs more than the 1-year-old. Okay? So because of this, weight is the dependent and age is the independent. Our second example, we deal with the time spent studying and the test score. Does the time you spend studying depend on the test score, or does the test score depend on the time studying? Well, similarly, I would hope that the time spent studying will be your independent variable. It will be your input, and your test score will be your output, or your dependent variable. Okay. And finally, we have our income, the number of an item sold. Will your income depend on how many of an item you sold, or will the number of items that you're able to sell depend on the income? Well, hopefully you guessed this. And we can say that the number of an item sold is your independent variable, and the income is your dependent, because the income kind of comes after you sell the items. This will probably take a little bit more practice to get this step, but I think the more you can look at this statement here and use this to help you decide what depends on what, I think it'll become a little clearer. But you always have to think. This is a situation where you really need to apply your brain and kind of what you know about life. Hopefully this has been helpful and will prepare you well for tomorrow.